All right. So now that I've calculated my min and max slope, now I've calculated my total percent uncertainty, I am finally able to get to the end of my, get to the conclusion, to get to the end of my analysis. So you are going to start off by saying, conclusion, this is what I found. Okay. This is my total percent uncertainty. This is my variation in my slopes. So none of this bull crap that you guys like to pull that I found the acceleration due to gravity to be 9.8, which is exactly what I expected it to be. I am perfect. Hear me roar. That does not happen. Okay. Even if you do have a percent discrepancy from the actual value of 0%. Okay. Even if that is true, you don't get to pat yourself on the back. You just got lucky. Okay? So let's talk about everything you're going to want to do. So you're going to list your value of your slope. Okay? Slope value. You're going to list the expected value if you have it. In many of your experiments, you're not going to have an expected value. That is okay. But if you do have the expected value, if you are looking for the acceleration due to gravity, list your expected value. Okay? Then next, you are going to talk about your percent uncertainty, which is your total percent uncertainty. You don't have to talk about the individual ones yet. You're just going to talk about your percent uncertainty. And I'm a horrible speller. I don't care. Well, I do care. You're going to talk about your min slope. And then you're going to talk about your max slope. And you can compare your min and max slopes to the expected value if you have it. If not, you can just talk about it as a variance from what it potentially can be. Kind of tells you how good whatever your apparatus is. Okay? Like, you can't sell this as being 100% effective if you have a min and max slope. Cool? The next part of this is you are going to look at your percent uncertainties, but you're going to look at your percent uncertainties individually. So you're in my experiment, I'm going to say, here's my time uncertainty, here's my distance uncertainty, whatever other uncertainties I have, and I'm going to look at them to see which one has the larger value versus the smaller value, and I am going to not list them. I'm going to start with my largest value, say that during the course of this experimentation, I was able to determine my time uncertainty to be about 22%. Then, with the largest value first, talk about methods in which you can reduce that uncertainty. Then move on to your distance, move on to any other uncertainties you have, going through the process of identifying the greatest uncertainty should lead off your discussion on the things that you should fix, ending with the things that have the smallest uncertainty, which play little effect on your total uncertainty. You don't want to lead off with a conversation saying that I need to have a better braided wire when your number one problem was measuring the luminosity of the light bulb using pieces of paper. I don't know. Okay? You want to start with your largest uncertainty first and then move through the process. Okay? After that, you can talk about any things that were not controlled. Okay? So if you had run the experiment and realized that as I was baking cookies, the humidity in the air was dropping because the sun was coming up and there was more things that are kind of the atmosphere was getting drier, then you're going to have to mention that. If you have an expected value and you have a total percent uncertainty and your expected value is off from your measured value by a significant amount, then you're going to have to explain where you went wrong. Okay? There is one thing I forgot to mention here. If you have an expected value, this is what you should do with your expected value. You're going to take the difference of your slope and your expected, and you're going to divide by your expected absolute value of that times 100%. And that is what's called percent discrepancy, which means that I have an expected value and I have a discrepancy from that expected value. If you were to do it another way, in which you were, let's say, testing the spring constant of a spring, and you used harmonic oscillation for one method and you used the Hooke's law for another method, so that you've got two slope values for it, which you shouldn't be doing, you could take the slope value of one minus the slope value of the other divided by the average, and you get what's called a percent difference. So percent discrepancy is talking about if you have an expected value, you can calculate the percent discrepancy. If you've ran multiple experiments using different methods, you can take a percent difference. But for the most of you, you're not going to have an expected value, and you're not going to have multiple trials of different or multiple experiments finding the same thing. So you're just going to look at your slope value, you're going to look at your percent uncertainty, and you're going to talk about your errors. Now, the other thing that IB wants you to do is take a more holistic approach to this. So you should take a time to talk about the process of doing this experimentation. Cool? So that is kind of the breadth of your analysis. There should be, there's a few more bullet points, but this is like the nitty-gritty of it. Like always, you should look at the rubric to make sure that we've covered all of your data. Like if they're saying, oh, in this, make sure that you mention this. I won't be able to cover all of this information, but I do want to cover the heavy hitters on it. But please go back through and examine that rubric when you get a chance.